Hello, I'm Professor Mark Meiskens, and I'm one of the 3 lab instructors for Chem 102 lab this semester. And I'm going to give you some introductory remarks about this lab that we have for this week, which is entitled Freezing Point Depression. And this is going to piggyback on what you're doing in class, where you've talked about a phase diagram for a pure substance. And we will be measuring a freezing point of a pure substance, and that's going to be lauric acid. And then we're going to make a mixture and see how much that freezing point changes. And that discussion happens to do with where you're talking in class about making up solutions and the properties of solutions, and even colligative properties, where placing a certain amount of a substance in a mixture will create a certain amount of change in the temperature, which is a freezing point depression, or a lowering of the freezing point. And so into our lauric acid, once we have measured its properties, we're going to mix a little bit of what we're calling an unknown compound. That is, it's not known to you, and you're going to figure it out in lab. This is a little bit of a detective challenge. So once you add a known amount of this mass into the pure sample, you'll have created a mixture. You'll know the mass of it, but the change in the freezing point will allow you to figure out what the concentration is. And with that together, you can find the molar mass of this unknown compound. So that's your challenge, is try to identify this compound. One of the challenges here is to work with the masses of these so you can accurately make a solution. And so I'm going to talk for a little bit about how to use these mass balances, and that's why I'm here in the laboratory. You can see this is our Gen Chem lab, and I'm set up here by all these balances that are here against the wall, against this glass divider between labs. And this balance here is called an analytical balance. It's the one with the doors on it. And when I read this scale that it displays for the mass, it's reading to the nearest tenth of a milligram. That is, in grams, it's got 4 decimal places to the right. And so it's very accurate and very precise. It has the doors so that there's no air currents to affect the measurement. And I'll walk a little further away. We have over here a second balance. This balance is what we call a top loader balance, and it's good to the nearest hundredth of a gram. So it only has 2 places after the decimal place, but it's obviously easier to use since it doesn't have the doors constraining the space. It's less sensitive to currents in the lab, and so it doesn't need doors. And so I'm going to just describe a way that you can measure out a certain amount of this lauric acid, and how we can combine these 2 balances to do this really very easily and very accurately. Now, your lab is going to tell you that you need about 4 grams, but you want to know exactly how much you put in there. So it's an interesting concept in the chemistry lab, where the exact amount isn't critical, but knowing exactly how much you have is critical. And that's just an interesting concept. So we're telling you we want about 4 grams. It could be plus or minus a tenth of a gram. That'll be perfectly fine. But we want to measure accurately with the analytical balance how much you have to the nearest tenth of a milligram. So a really very easy way to do that is to take a weighing boat. It's this little flexible plastic weighing boat. I'm going to take it over to this this top loader balance, and maybe I'll take you along over there. And we want about 4 grams. So we put this on the balance, or weighing boat, and we're going to make sure it reads 0. And now I'm just going to get about 4 grams in here. And I can see that it's going up, and it jumped way high. Now that's because a big chunk came out. And that's not what I want. I don't want that big chunk in there. Now normally in a chem lab, we wouldn't want you to put things that you've already removed from a chemical bottle and put them back in. And in this lab, because we are working with these smaller amounts and I have these big chunks, it's best if I didn't have this really big chunk in here. And so I'm going to pour it back in, and I'm trying to avoid having big chunks. So maybe I need to kind of get rid of that big chunk in there. I'm at 2.65, and now I'm at 4.33. That's a little bit over. I can put a little bit back in here. 3.65, and I would just now want to gently tap and wait, and I've got 3.97. So that's close enough to 4. I'm not going to fuss around and try to get it like 4.00. I know it's close to 4. Now I want to know exactly how much I put in there, and I want to put it in the vessel that I want to measure. And so here's our analytical balance. And here's the thing that I want to put it in. I want to put it in this test tube. And I want to know exactly how much I delivered to this test tube. So on this analytical balance, and trying to weigh something as awkward as this test tube, we have this plastic cutout device so that the test tube can just nestle in there. And it also has a magnetic stir bar in there, which is what we're going to end up wanting to have in there once we've melted the sample. So I'm taking this combination of the support, the test tube, and the stir bar, and I'm putting them in the analytical balance. I'm turning it so that the test tube is kind of pointing out the side. I close up the balance and I press the bar, and that is going to give me, that's what we call tearing, and it gives me a value of 0.000 on the scale. So now, when I pour something in here and weigh it again, it'll tell me exactly how much I added. And the weighing boat actually allows me to kind of fold it into a kind of a funnel. And I can pour it right into my tube. I want to be sure that I get it all transferred, even the bigger chunks. And there's even a little bit of dust on here, but that's not critical, because what I want to know is how much did I get in my test tube, and I read that right off the balance. And so now I can write down the mass, and so we'll have a report sheet that you can write this down, and I'm going to write 3.9335 grams. So I've now measured that mass to 5 significant digits, and I have a very precise measurement of how much is in this test tube. And it's that easy. So I'm not trying to fuss with the analytical balance to get close to 4. I'm using the top loading balance to know that I'm around 4. I don't need to write that number down because I'm going to transfer it to my test tube, and I've got an accurate measure that I write down for that mass. So now I'm going to show you that we can melt this easily. We are going to have in the lab a beaker of hot water, and this one I have a thermometer which shows me it's at a little over 60, and right now I have the setting of the heater at just between 3 and 4. And I'm going to put this test tube in here, and this water now is warm enough that it's going to melt this lauric acid. So I showed you that it's a powder, and but it does have a melting point that is not terribly high. You're going to measure it in the lab. And you can see this water that's a little above 60 degrees is enough to melt the sample, and you can see it's already started melting. So I'm just going to let this kind of melt. And next to this, I have a stir plate with a clamp that I can place my test tube over, and that's where we're going to actually measure the temperature. So it takes a little bit of time to melt this sample. I don't need to test the thermometer in there the whole time, and that gives me a chance to do a swirling, and that will help speed up the melting process. I also happen to have my magnetic stirring plate on, so I can actually go over here and I can stir it a little bit by holding it over the stir plate. And we are still needing to melt some of this. So there's a little solid there still melting, and this is leading up to where you're going to be able to measure the freezing temperature of this liquid. So we want to get this completely melted, and once we have this melted, I can show you how we're going to measure the freezing temperature. So now I can show you that we've got, basically we've got a liquid here because we've melted it, we've brought it above its freezing temperature, and it's nicely melted, okay? So I can put our temperature sensor, just like we used in the previous lab, and I place it in with a rubber stopper, and that gets the temperature sensor in the center right near the stir bar. And when I place that in over the hot plate, over the stir plate, it's now stirring, and I have Lager Pro running here, and the temperature is a little bit below 50. I want that temperature to be above 50, and so I'm going to warm it a little bit, and let's see if we get above 50. We are above 50, and I'm going to start collecting. And the feature of this Lager Pro that you're going to download from Moodle is that it will, even though I've clicked collect, it's not started collecting yet. It's going to wait until this temperature drops below 50. So it's set up so that as soon as you click collect, it will wait for the event that the temperature is above 50 and drops below. And you can see here we're cooling, and we're down to 51 degrees, and our tube is sitting here above the stirrer. It's a liquid because it's above its freezing temperature, and we're about to get 50 degrees. So we're now cooling. We've dropped below 50, and now I've started collecting time and temperature, and a new curve is showing up on my screen. So this is the process by which we're going to watch for a freezing temperature. I have this set up so it shows you a couple curves in here. One is for the pure lauric acid, and one is for this mixture, and I haven't identified which mixture that is for you, so it doesn't provide any clues about what you might get. Your unknown might turn out to be a different one from this one here. So I'm going to probably stop this. It's going to keep going down, and we're going to look for a chance where we get this inflection point, and that inflection point is going to tell us something about, is going to be where we can identify the freezing point for pure lauric acid. Now, when we're done getting this freezing point, let's just stop it now. You probably want to see it all the way, but I'm going to stop it. What I want to show you is how to measure now making a mixture. So that's the process of going through to find a freezing point for this. But when we're done with that measurement, we are going to want to make now a solution. We're going to add a solute to this. This liquid of 4 grams, about 4 grams, is the solute. And I want to show you how to use the mass balances to make the mixture. So we're going to add some of this unknown, and that's going to be the solute that dissolves in this liquid. So one trick is that I want you to try to avoid getting some of this liquid spread along the side of the tube. we're going to add some of the solute, and we want that solute to drop down and get into the liquid. And if we have much stuck on the sides, that solute will get stuck on the sides of the test tube and not get mixed into the mixture. So I'm going to loosen the stopper, and I'm going to try to carefully lift the thermometer straight out. And now notice there's a little bit of lauric acid on the end of the thermometer. I don't want to lose that. I want that to stay on the thermometer, and I want to be sure that it goes back in. So I'm going to set this and not let it touch my plate. And now the little bit of lauric acid that's on that thermometer is going to go back in here. Now I want to demonstrate for you how to add the solute using our balances. So this is the same kind of process we had before, which is I want to add some of this unknown. For unknown A, tells me I want around 0.8 grams. Now, the more mass you put in, the larger the freezing point depression is, but our recommendation is around 0.8 grams to get a good result. So, I'm going to grab my test tube support so it doesn't fall over and leak lauric acid all over the place. So that's setting right here. And I'm going to take a smaller boat. This weighing boat is a smaller one. It's just as flexible. And in here, I'm going to try to measure out 0.8 grams of this unknown. So once again, I'm going to take you down the aisle here. And what we want to do is we want to put this boat on here. And now, of course, I get a negative value because this weighs less than what we weighed before. So I'm going to hit tare. It says 0.00. And now I want to take some of this powder. And this one doesn't look like it's as chunky as the other one. So maybe it'll pour more nicely. So I'm going to go and just tap to allow some of this solid to go in. And I have to wait and see what the result is. So I'm at 0.8. I'm at 0.08. I want more than that. So I'm just going to be kind of careful. It's best if I just kind of approach it. I don't want to take too much time, but now I'm at 0.64. And you wait for the new amount. And I'm at 0.76. Now that's pretty close to 0.8. I have to decide, do I want a little bit more? I might go over. Another tap. And now I'm a little bit over. I'm at 0.84. And 0.84 is close enough to 0.8 that we're just going to use it. So, that I don't need to measure so accurately. I want to do that accurately over my analytical balance. I want more precision in the measurement. So, here we go. We have our test tube with its lauric acid, stir bar, its support. That goes on the balance. Okay, I'm going to hit the bar, and that's going to zero that out. So that's now tared. Got zeros, and now I want to go and take my little boat and weigh and pour this in. Now I'm going to do this so it's kind of vertical, and I'm going to pour it like straight down. And now I've added my mass to this. I'm going to weigh that whole business. And now I can read off of my balance a new mass. And that says 0.8408. Now it was less than a gram, so I only have 4 significant figures, but it's measured all the way out to a nearest tenth of a milligram. And so I know that mass really pretty accurately. Okay, so now that is what we're going to have as a mixture, and that's going to come over here, and we can use our hot water bath to melt it. And we'll put that over here on our apparatus. We can slip our test tube in there. We want to be sure that all that solute gets dissolved into the lauric acid. That's going to give us that new mixture, and the freezing point depression is going to help us to know what the concentration is. The concentration units will be molality, so you'll have to take that into account. Those units, a different unit of concentration. And if I want this to stir a little bit, I can stick it over here on my stirrer, come back over here, and we're almost completely dissolved. So the next trick is something chemists have to do, which is to judge that we've got complete dissolution of our solute. And here you can see that there's still particles in there. So I stir it a little bit. Stirring helps. Heating is important. Stir a little bit. One of the challenges in my research projects is that we're trying to dissolve something that's not very kindly dissolved in water, and we're trying to make sure that it's completely dissolved. So this is pretty good. It's got a few particles floating around in it a little bit. A little bit of stirring might be all that's needed. I'm going to warm it just a little bit more. A few particles, it's being a little bit stubborn, and we just have to heat it a little bit more. So this is the process. We're making this solution. The next step is just to find its freezing point, and now we're completely dissolved. So I'm not sure that your camera is going to convince you that we have completely dissolved this because it's got liquid on the outside, but I've dried it off, and you can see that it's perfectly clear. So that's completely dissolved. We will take our thermometer and slip it down the center of that, and that's what we want to find the new freezing point for. And when you open up your Logger Pro, you'll see there are two curves here, and one's lower than the other because that's the freezing point depression. So you'll find freezing points from these two, and that change in temperature will be what will give you that freezing point depression. You'll see how much that freezing point gets lowered by the amount that you precisely measured of mass of the solute, and you'll be able to calculate a molality that will allow you to calculate a molar mass, and that'll be a clue to help you identify that unknown compound. So this illustrates some of the ideas of phase change, illustrates some of the colligative properties of freezing point depression, but another key factor is kind of giving you some lessons on how to effectively use these balances. The idea of hitting the tare, using the top loader to get kind of close to the mass you want, use the analytical balance to very quickly get a very accurate measure of mass. So with that, I wish you the best in lab, and read the other preparations, take the quiz, and I'll see some of you in lab, and the others wish you the best. Stay well.